Hi, my name is Sunghyun Jang from Wireless Network Lab, and my article today is about Bert. Let me start the presentation. These are my contents. I will briefly introduce the topic, and I will give this description about Bert. My main topic today is related to language model. Pre-training this language model is widely used recently, especially in natural language inference, paraphrasing, and named entity recognition, which is represented below. To explain briefly, it is that machine indicates the name of specific information such as person, organization, or location. There are two strategies to apply this pre-trained language model. First, the feature-based approach, such as LMOS, uses pre-training to recurrent model like LSTM. Also, it uses a model as a context, and it is task-specific. Second, the fine-tuning approach, for example, transformer, pre-trains attention module. It is trained on downstream tasks instead on that task. This is the mechanism of transformer, which is widely used for machine reading. As it is not our main focus, I will pass to next topic. The limitation is here that current file tuning techniques restrict the power of the pre-trained representations. The major one is that standard language models are unidirectional, means it can be translated only based on one side, although to understand natural language well, it should be bidirectional. Only previous token is attended to understand the context. The paper is trying to improve this. Now the paper proposes Bert, which states it for bidirectional encoder representations from transformers as a method to improve fine-tuning approaches. It is a language model that masks some of the tokens from input representation and then let the model predict original token based only on context. For understanding, let me show the example below. Next, for the input of Bert, single sentence or pair of text sentence is both available. For example, question and then answer. They can be paired up together. And then it is rather called a sequence or a task. Then I will explain about pre-training tasks of Bert. As Bert would use bidirectional training dataset, there is a problem that this kind of training would make each word refer itself in multi-layer context. To cover a bit, in training procedure, it will change some of the words in sentence to mask token and make Bert predict the missing word as I explained before. However, there is two downsides. First, the mismatch occurs between pre-training and fine-tuning, as mask token never appears during fine-tuning. To resolve this, rather than always replacing with mask, it would give another word or just let the word unchanged. The next problem is that the number of tokens trained is not enough. It's just 15%. So we need further steps to make it converge. For the next pre-training task, there is next sentence prediction. The objective is to understand the relationship between two sentences. The latter sentence in training procedure is chosen randomly with probability of 50%. According to the experiment, the final model achieved 97 to 98% of accuracy at this task. Thank you for listening my presentation.